All right, so here we go, 3.4. More properties of logs. So we're just going to carry over from the logs from last time. I know this only looks like 3 pages. Most of this is practice using the 3 properties that I'm introducing now. The first one is the product property. It says that if I have the log of 2 factors, 2 things that are multiplied, I can rewrite that as the log with the same base of the first factor plus the log of the same base with the second factor. My favorite instructor from my college, from my undergraduate, was Dr. Barnes, and she taught us the silliest way to remember this. And it's one of those jokes where it's like I know the punchline, I see where this is going, and I can't stop it. And there's no getting out of the way. If I have log of C plus log of A plus log of B plus log of I plus log of N, I have log cap. Plus on the outside means multiply on the inside, and likewise, division on the inside means subtraction on the outside. So the first one's product property, second one is the quotient property, and the third one is going to be one that's important. All these are important, but the power property is one of the reasons that we teach logs. And it says if I have the log of something raised to a power, I can rewrite that by taking the power, sticking it out front, multiplying it by the log base b of the base of what was inside. So the power goes out front. This is very useful for us because we have exponential equations now. Exponential equations have the variable in the exponent, and we've never talked about how to solve those. The only way we know to solve exponential equations at this point is if I had 3.4x is equal to 3.4 to the 7th, right? I need the same base so that I can say, well, if the bases are the same, the powers are the same. Now we can talk about solving problems like this. I don't have the same base. I'll never have the same base. But now I can manipulate this into, I can get that variable out of the exponent. But I'm getting ahead of myself. The main 3, these are the big 3 properties of logs. So we're going to use these properties to, in this section, combine multiple terms into a single log. So the first one here, log base 3 of x plus log base 3 of 7. I have a addition on the inside, or I have addition on the outside, which means I can rewrite this as multiplication on the inside. So log base 3 of x plus log base 3 of 7, log base 3 of x times 7, and yes, I would typically swap that order and make that 7x. Both are correct. All right, so in these cases, we're simplifying is not a good word to use in these because sometimes you are asked to condense or compress multiple logs into a single, and sometimes you're given a single log and you're asked to expand it. So in these, I'm taking multiple logs and writing them as a single. Next, I have subtraction on the outside, and I say outside. What I mean by that is the arguments of the log are the inside, right? There's nothing inside the parentheses, nothing. I'm not taking the log of something with a subtraction in it. I'm not taking the log of something with a subtraction in it. So when I say it's on the outside, I mean I'm subtracting 2 terms that have the log. The bases are the same, which means I'm allowed to rewrite this. Log base 3 of subtraction on the outside means division on the inside. Okay. Looks like I gave myself a little bit too much room, but that's okay. And so we've done those 2. Both of those were rewrite multiple term logs as a single log. Next, we have, and let's make sure this is clear, this is the product rule. This is the quotient rule that's at work here. You're going to use these in both directions, right? Sometimes you're going to have your logs separated into different terms. Sometimes you're going to have one log and you're going to be asked to use the product rule or use the quotient rule to break it apart. The next one's 7 times log base 3 of x. In this case, it's already written, so there's a coefficient out front, and I'm taking log base 3 of x. Well, the quotient, or excuse me, the power rule says if I have the log of something raised to a power, I can bring the power out front. It turns out we can do this both ways. If I have my p times log base b of m, if I have a log with a number out in front of it as a coefficient, I can bring that inside the argument and make this log base 3 of x to the 7. Right? These rules go both ways. The 7 comes inside. I did put parentheses here. Just again, this is why I was trained, so you're going to see those a lot. And let me be clear, that's not raised to a power or offline or anything. X to the 7th. And then next, natural log of 3a. Let me write this. This is power rule. Next, I have natural log of 3a. This is multiplication on the inside. So this is the product rule. And it says I can rewrite this as the natural log of 3 plus the natural log of a. And there's nothing left to do there. Natural log is going to be your friend. We're going to use it a lot when we start solving exponential equations. So just keep in mind natural log is just log base e. That's all it means. It's just a special case of the log, just like the common log. And let me just move these two up. I don't know why I thought I was going to write in gigantic letters, but I guess I thought I did. Last two, log of 5 over a. This is the quotient rule. Because I've got division on the inside, which rewrites as subtraction on the outside. Nothing left to do there. That is the common log because there is no base written, so that's an understood 10. Notice if it's the log with no base, that's the common log, base 10. If it's natural log, it's base e. And if it's any other base, they have to give it to you, right? Here, the base is 3, they had to write it. Here, the base is 6, they had to write it. That's always the case. Okay? If the base is anything other than 10 and e, they'll have to tell you what it is. And then next, I have the log of something raised to a power. So guess which rule I'm going to use? That's right, the power rule. Power rule says that if I have the log of something raised to a power, I can bring that out front. And then I just rewrite log base 6 of a. Notice the power doesn't stay, the power doesn't remain inside the parentheses. It literally just moves out front. It goes from a power to a coefficient. Okay, so those are the 3 rules that we're going to be using to deal with this section. All right, so let's do some practice. And rewrite these logs as the sum or difference of simple logarithmic terms. Express all powers as products. Okay, so this is going to require using multiple rules. Everything we just did on the last page was just a single rule. So right here, you see a couple of things as you're looking at this. I have log base 3 of 7x squared. Now, if you're looking at this, you're saying, oh, I have a power. Yes, you do. And the power rule is going to get used. But this entire argument is not raised to that power. So I can't use it because I need to be taking the log of something raised to a power. What's going on the inside here, though? That's 7x squared. 7x squared means 7 times x squared. That looks like the product rule, right? So the product rule says if I have multiplication on the inside of the log, I can rewrite it as addition of the factors on the outside. So now I have log base 3 of 7 plus log base 3 of x squared. Notice the base stays the same as you break these up and bring them together. As you break them up, the base is always the same. As you bring them together, they have to have the same base to start. Next, log base 3 of 7. 7 is not a perfect square, right? So I can't make this into, like 4 squared and then bring the power out. But that x squared has a power. So by the power rule, I can, first term is done. And again, just a quick reminder, terms are separated by pluses and minuses, factors are multiplied. So I say the first term, log base 3 of 7 is a term. 2, and I do put the dot there to help, log base 3 of what? Of x. Is there any more I can do for that? Nope, that's it. I don't have, so go down the list. Let's look at what we started with and look at what we ended with. We ended with addition and subtraction of simple logs. Perfect. Is there any more to do? Well, I started out with a combined, written as one log. I've broken them up. Log base 3 of 7. There's no multiplication on the inside. There's no division on the inside, and there's nothing raised to a power left. Other term, nothing, no addition inside, no subtraction inside, no power on the inside. If the answer to both of those is no, then you're done. All right. Next, I'm going to scroll down and get some easier ones out of the way first before we tackle that monster up here, because that's got multiple steps. So next, and this will be all right. Log the square root of 5x. Now, square roots, when we think about, so I want you to think about order of operations. In order of operations, we do parentheses, exponents, multiplication, division from left to right, addition, subtraction from left to right. Square roots aren't in there. And the reason they're not in there, there's no special like parentheses, exponents, square roots. Please excuse my dear sweet Aunt Sally, doesn't work. So turns out that a root, and you already know where this is going, turns out by taking a square root, whatever the index of that root is the denominator of the fractional power that I'm dealing with. So a square root can be rewritten as the 1/2 power. A cubed root would be written as a power 1/3. Why did I do that? Well, there's no rules for how do I manipulate a log that has a root in it. There is a rule for how do I manipulate a log where I have something raised to a power. And what is that rule? It's the power rule. And the power rule says I get to bring that 1/2 out front. Why is it different than the one above? Because 5x, the entirety, is raised to the 1/2 power. So that's why in this case, the power rule gets used first. That's 1/2 times the log of 5x. Now, I put parentheses in here to really drive the point home that the square root is covering the 5 and the x. So then you see the brackets go outside of it just to remind me this is what I'm taking the log of. The brackets disappear because I don't need them. Once the power goes out front, I just go back to parentheses. When I'm doing brackets and parentheses, they're interchangeable. All right, so next, log of 5x. Well, that's the product rule, right? I got multiplication on the inside. So that means I have 1/2 times, that's log base 10 of 5 plus log base 10 of x. Now, that 1/2 is multiplying log of 5x. So whenever I have a coefficient and I have a log that I can break up using the product rule or the power rule, I do need to indicate that that 1/2 applies to the result, right? Log of 5x is the same thing as log of 5 plus log of x. So 1/2 times log of 5x has to be the same thing as 1/2 times log of 5 plus 1/2 times log of x. So my final answer is going to look like this. 1/2 log x. Can I do anything else? There's no multiplication, division, or powers left inside the logs, so I'm done. Okay. Next, let's bring in the natural log. I got the natural log of e times x. For this, again, I have a product on the inside. So it's a product rule problem. So natural log of e times x is the same thing as the natural log of e plus the natural log of x. And now, can I do anything else? Are there any powers? There's no multiplication, there's no division, and there's nothing to a power. But I do have a property that I need to take advantage of. I have the property where the base of the log matches the argument. And I forgot to spell argument there for a second. All right, now what do I mean by that? Take a look, natural log of e. What is natural log? That's log base e, right? It's not blatantly obvious if you don't write log base e of e. It would be helpful if I wrote this legibly. Log base e of e. What happens here? When the base and the argument match, the answer is 1, right? Log base e of e. What power do I raise e to get e? 1. Okay. And that's it. All right, so we're bringing in the multiplication, we're using the product rule, quotient rule, power rule, and we're going to be using properties that we have encountered along the way. All right, now I'm going to run back up to the top and deal with this monster. When I wrote the problem into the notes, I was not very specific with my brackets here, so let me just drive home the point. This is the natural log. Everything in there is raised to the third power. All right. So what is the outermost? What's going on in this problem for the outermost? Well, I have a fraction, so it looks like I'm going to have the quotient rule at some point. But that entire fraction is raised to the third power. So right off the bat, I need to deal with the power rule. Right? I can't break up the numerator and denominator, or I'm not going to break up the numerator and denominator, when I have a really easy starting point. 3 times the natural log, and I've been writing whenever I use the power rule, I've been writing that in red just as a reminder. 3 times the natural log. The power is gone, so you're not going to see me use multiple brackets here. 2x plus 3 over x squared plus 3x plus 2. Now I have the log of 2x plus 3 divided by x squared plus 3x plus 2. What's next? Well, the denominator is a quadratic, so let's deal with that. Does it factor? Let's find out. So I have 3 times the natural log of 2x plus 3 divided by two numbers that multiply to 2 and add to 3. Those exist. That's 2 and 1. Why would I take the time to do that step? Because, and you could do this step later. Why would I do that step though? Because there's a chance that one of these factors actually divides the numerator and simplifies the problem. They didn't, so we're right back where we started, but we have broken up the denominator into two factors. Next step, okay, I've got division occurring. So that means the quotient rule is about to get used, and the quotient rule says if I have division on the inside, I can rewrite it as subtraction on the outside. So that's the natural log of the numerator minus the natural log of the denominator. Let me use brackets here so that you can really see the difference. X plus 2, just to really drive home the point that the denominator is brought out, and these brackets apply to the natural log. That's the second term, and this bracket applies to the 3. All right, let's see what else. I brought down everything but the writing. There we go. So let's distribute the 3 for now. That was usually the next step. And now I'm looking at 3 natural log 2. X's and pluses. I always do that. X plus 3 minus 3 times the natural log. And I did it again. Again, I'm driving home the point. I want it to be super clear that I'm taking the natural log of the product of those two. All right, well, I just kind of gave away the next step. How was I checking before if I was done? On the inside of the first log, there's no multiplication, there's no division, there's nothing raised to a power. This one's done. Over here, I do have multiplication on the inside, so this is the product rule, which is going to come out to play. First term stays exactly the same. Minus 3. Now remember, I said before, if I have 3 times something and I'm about to apply either the quotient rule or the product rule, that 3 is the coefficient for all of the results. So the natural log of x plus 2 times x plus 1 is the same thing as the natural log of x plus 2 plus the natural log x plus 1. And then I need to distribute that subtract 3, and I end up with 3 times the natural log of 2x plus 3 minus 3 times the natural log of x plus 2 minus 3 times the natural log of x plus 1. Okay, there's no more products, there's no more quotients, there's no more powers. I've done it right, I've done it correctly. The only thing that could still happen in these problems, in a problem like that, is I could end up with logs that have the exact same argument, so they could be added and subtracted. They're just like terms. But that doesn't happen here, right? The argument for the first log, natural log, is 2x plus 3. The next one's x plus 2. The last one's x plus 1. So I can't put those together. So that means I'm done. All right. Enjoyed watching me play with this piece, I'm sure. And the T somehow got split up into the up and the down. So that one's done, and then I have 3 more. I'm going to scoot this one up because I just don't like that. I don't like to waste space. So I have almost the same problem that is on the right. Natural log of x times e to the x. Same process. I do have a power, but again, the entire argument is not raised to that power, just one of the factors. So I can't use the power rule first, but I can use the product rule. And the product rule says if I have multiplication on the inside, I can rewrite it as addition on the outside. So natural log of x plus natural log of e to the x. The first term, natural log of x, is done. The second term is not, because I have natural log of e to the x. So now I need the power rule. And the power rule says I can take this power and put it out front. So then I have the natural log of x plus x times the natural log of e. And then I've done product, quotient, and power are done. Now the only thing left are the properties. Natural log of e, I got a same base. So the natural log of e is just 1. So what do I end up with? Natural log of x plus x times 1, which is the natural log of x plus x. I am going into more detail if you're able to follow that or do that without writing the 1 here and then showing 1 times x is just x. That's absolutely fine. Remember, this is for everyone. We're in class, we're not in class, so I'm going to go into as much detail as I can. Next, I have log base 2 of x cubed divided by x minus 3. So what do I do first? Well, when you're running down the list of properties, you get the product, quotient, power. You want to deal with what's the outermost operator that you're looking at. So if is the outermost thing a power? No. The entire argument is not raised to a power, just parts of it. So it's not power rule. There's an exponent in there, but there's no multiplication. There is division in there, and that's the big starting point. I have log base 2 of x cubed over x minus 3, and the quotient rule says I can rewrite this as log base 2 of the numerator plus log base 2 of the denominator. All right, so quotient rule has been used. Next is the power rule. The power rule, because of the first term, the power rule says that cube, that 3, gets to come out front. And now I have 3 times log base 2 of x plus log base 2 of x minus 3. Now, here is trouble. There is no multiplication, division, or powers left in the arguments. There is a subtraction, though, and this is where we have to remember our rules. Subtraction on the inside doesn't do anything for us. It's multiplication on the inside turns into addition on the outside. Subtraction on the outside turns into division on the inside, or division on the inside to subtraction on the outside. Okay? I can't go any farther, even though you might want to. You may feel like you should. I cannot break this up. You cannot make this into log base 2 of x minus 3 log, or minus log base 2 of 3. You cannot split that up anymore. Right? So if multiplication, division, and powers are all gone from the inside, I'm done with the 3 properties. And then lastly, we're going to put this mess in here. Notice we've had to indicate the domain because this falls apart. This doesn't work for a lot of values of x. So I've got the natural log of 5x squared times the cubed root of 1 minus x, all divided by 4, times quantity x plus 1 closed quantity squared. So what's the big thing? What's the most outside function that's going on here? If it's not power, which is not there are some things raised to powers, but not everything. So first thing I'm going to use is the quotient rule. And the quotient rule, good gracious, Larry, letters are so hard today. And the quotient rule just lets me break this up into the natural log of the numerator, 5x squared, times the cubed root of 1 minus x, minus the natural log of 4 times x plus 1 squared. All right, now let's go one step further. Actually, let's not do that yet. Both of these terms have products in them, right? 5x squared times the cube root of 1 minus x, 4 times the square of x plus 1. So I'm going to use the product rule to simplify both terms. I may need to use it again. Let's find out. Okay. So the natural log of 5x squared plus the natural log of the cubed root of 1 minus x minus, now I'm about to break up this second log into addition of two logs. So that minus needs to apply to both results. So that is minus the natural log of 4 plus the natural log of x plus 1 squared. Okay? And then when you distribute that negative, these all become negative. So let me do another step here. I'm just going to rewrite. Take a look at my first log. My first log still has some product rule in it, right? So I have two things that are multiplied. So I'm going to apply the product rule again on this first term. I'm going to rewrite the power, I'm going to rewrite a root as a power here, which that's not a rule, that's just a property. And I'm going to distribute that subtraction. So let's do this, all this in one step. Natural log of 5 times x squared is natural log of 5 plus the natural log of x squared plus the natural log of, that's 1 minus x, raised to is the cube root, so that means that's raised to the 1/3 power, minus the natural log of 4, minus the natural log of x plus 1 squared. Okay, now what? Well, I have 3 cases. Not every term has it, but I have 3 cases of power rule, right? I have a log of something raised to a power in the natural log of x squared. I have the log of something raised to a power of the 1/3, that cubed root. And then lastly, I have a square down here. Power. Ooh. And I'm going to do them all at once. That 2 goes out in front of the log, that 1/3 goes out in front, and that 2 goes out front. So where am I at now? I now have the natural log of 5 plus 2 times the natural log of x. Remember, what's left inside the argument afterwards is just the base, not the power it went out from, plus 1/3 times the natural log of 1 minus x, minus the natural log of 4, that didn't have anything done to it, and then minus that 2 comes out front, times the natural log of x plus 1. Is there anything else to do? There's no multiplication on the inside, there's no division on the inside, there's no powers on the inside of any of the logs, so that means those 3 rules are done. I don't have a match, I don't have a case where I have a base that matches the arguments. And last thing to check is, do I have any like logs? Do I have any logs that have the exact same argument? natural log of 5, natural log of x, natural log of 1 minus x, natural log of 4, natural log of x plus 1. Nope, none of them match, so they cannot be combined, which means my answer is all of that. And again, they told us at the beginning to rewrite these logs as sum or difference of simple logs and all powers written as products. So that is, 7 examples that we've done. The last one was obviously the most difficult because, and I don't get the sense any of these are particularly difficult so much as they're just extensive. They take writing and time. All right, so last page of the 3-4 notes is we're going to go the opposite direction, and instead of taking a single log and consolidating it taking a single log and expanding it out, I'm going to take a set of terms. I'm going to say where I have terms with log in it, multiple terms, and I'm going to condense it, or I'm going to compress it into rewritten as a single log. So we're just going to do the opposite of what we just did. First one, log base 6 of 9 plus log base 6 of 4. Notice I can't really do anything with this the way it's written because I don't know what power do I raise 6 to get 9, what power do I raise 6 to get 4. Nothing's jumping out at me here in terms of numbers that would work. So I'm going to use the product rule, but it's going the opposite direction. Instead of saying there's multiplication on the inside, which becomes addition on the outside, I have addition on the outside, so that means this can be rewritten as multiplication on the inside. So log base 6 of 9 plus log base 6 of 4 is the same thing as log base 6 of 9 times 4, which is 36. And look at that. Log base 6 of 36 is 6 squared. And whenever I have a base and an argument with the same base, the answer is the exponent. So this comes out to be 2. So notice I couldn't solve the logs, or I couldn't figure out what are the values that make, what is a log base 6 of 9, what's log base 6 of 4. But when I put them together to consolidate them into a single log, I did end up with something that I could simplify. Next, e to the negative 7, e to the negative 7, I can't even talk, e raised to the natural log of 7. So remember, what does this mean? What do I do with this? Remember, that's e, natural log is log base e, right? And whenever I have a matching base and a log in the exponent with the same base, I end up with just the argument. So e to the natural log of 7 is just 7. And that one's a rule. I really don't want to get into why that works. That one's just a rule I want you to keep in mind. Okay. Next, natural log. Let me come over here. I didn't put any problems on that side of the screen. Let's do that. Natural log of quantity x minus 2 minus natural log quantity x 2x plus 5. What am I about to use here? Well, I have subtraction on the outside. Subtraction on the outside calls on the quotient rule. Subtraction on the outside is the same thing as division on the inside. So that's the natural log of x minus 2. Oh, don't need a parenthesis there yet. Divided by 2x plus 5. Okay, not thrilling. It's all done in one step. I gotta yank the last one back up. Not intense or not labor intensive or anything, just that's it, right? The whole goal, and remember, this is, I spend most of my time in math trying to, the question you have to keep in the back of your mind all the time is, what is my goal? My goal is to rewrite this set of terms with log in it into a single log. Have I done that? Yes. Is there any more to do? No. And if there was anything left to do, it would be to maybe do some division on the inside if maybe the numerator and denominator has a common factor. It doesn't, so it doesn't simplify anymore. So I'm done. Next, I got a couple of things going on here. I have addition on the outside, and I have an exponent. I have a coefficient, which I'm going to make an exponent. Okay, so this is the power rule is going to be the first step. And why would I do that? Well, the reason I would do that is the other step you could do here would be to rewrite the addition as multiplication on the inside. But if I bring that 2 in, it changes how the problem sets up. So this is log of x squared plus log of x minus 1. And now, product rule comes into play. The product rule says if I have addition on the outside, that can be rewritten as multiplication on the inside, x minus 1. And if you want to complete that, if you want to distribute in there, you absolutely can. That's log of x squared times x is x cubed, x squared times negative 1 is negative x squared. There's nothing left to do. They're difficult to bounce back and forth between because when we're asked to expand a single log into terms of simple terms of in logs or simple logs in terms, everything we do goes backwards, right? On the last page, I was telling you to take that single log and break it up. Now I'm telling you to take all the logs, put them together. You have to remember the goal. The goal is to rewrite this as a single log, and we have succeeded.